I'm Hari from BLX team. Myself along with my colleague Gautam are going to walk you over the Citrix ADC BLX and how we are going to deploy the Citrix ADC BLX using Terraform. This video has two sections. The first half will cover about the Citrix ADC BLX Basics and the second half will cover about the Terraform Basics. In Citrix ADC BLX Basics, we will try to understand what is the Citrix ADC BLX and why we need the BLX. Then I will walk over how to manage a BLX, and we'll discuss more about the different deployment modes available. And we will also identify when to choose what BLX mode. So to begin with, Citrix ADC BLX. Citrix ADC BLX is another form factor in the Citrix ADC lineup. It's very much similar to the other form factors like MPX, VPX. The main difference here is the BLX runs on top of the Linux and it doesn't need any hypervisor, so that's make it unique and easily available for any customer. So the ADC BLX can be packaged using any standard Linux package manager, and the regular Linux utilities like systemctl can be used to start or stop the BLX, and the configuration of the BLX is controlled using the blx.conf, similar to any other Linux application. And currently, Citrix ADC BLX runs in both non-DPDK and DPDK environments. And when it comes to configuration, BLX leverages all the capabilities of the MPX and VPX. So why BLX? Since BLX can run on top of Linux, it has its own set of advantages. For example, it becomes cloud ready on day 0 because BLX can run on any VM which is running on cloud. Hence, we don't need to certificate it. The management becomes easy because it can be monitored and managed using any standard Linux tool, and it can be easily installed and also managed using the standard orchestration tools like Puppet, Terraform, or Ansible. And moreover, we are going to see how we are going to deploy BLX using Terraform in the later section of this video. The integration to the third-party tools becomes very easy, which also brings the coexistence into picture, which is not possible with any other Citrix ADCs. And the performance, because of the DPDK, we get a line rate performance on a commodity server. Next, how to manage the BLX, like how to install and how to start. So the BLX packages can be downloaded from the Citrix website under the Citrix ADC section, and based on the flavor of your Linux, you can either choose to download and install the RPM packages or the Debian packages. When it comes to RPM, we support CentOS, Oracle Linux, RHEL, etc. And we use the standard M utility to install or remove the BLX. When it comes to Debian, we support Ubuntu 18, Ubuntu 20. We will use apt utility to install or delete the BLX. And to start or stop and restart, we will be leveraging the systemctl. The entire configuration of the BLX is controlled using the blx.conf file, which will take the necessary parameters like number of cores, the IP address, the default gateway, and the interfaces, etc. Let's quickly see a quick demo of what we discussed so far. So this is a standard Linux host. It's running Oracle Linux 7.9. So I've already downloaded the RPMs and I've stored in this folder. The installation is very simple. As I told in the slides, it's just m install all the RPM files. It's done. Installation is done. So we can use systemctl commands to see the status of the BLX, to start and stop. So before doing that, I'll just quickly show you the blx.conf. So this is the blx.conf. As discussed, we have the worker processes to show how much number of CPUs are required to start the BLX, and we have DPDK config. In case of DPDK mode, we need to use the DPDK config. FF means we will be running it on 8 cores. Each character is a hexadecimal value that represents the CPU flag. And then we have the IP address, and we have interfaces and the different HTTP, HTTPS ports for BLX management, and even SSH port in case of shared mode. We'll be talking about the modes in the coming section. So let me change the worker processes to 5 and let me start. So we will see, yeah, we can see 5 different P's spawned up and they're running. Let's quickly check from the NSCLI. So yes, we are having 5 cores running on this BLX. So to stop the BLX, it's again very simple. Systemctl stop BLX, and we will not see any of these processes. Let's talk about the different deployment modes available in BLX. To start with, we have the BLX shared mode. In shared mode, the networking stack is shared with the Linux. What happens here is, we have a separate BLX network namespace, but none of the interfaces are part of the BLX namespace. Whatever traffic which lands on the Linux NICs has to be routed to the BLX. So we will be leveraging the IP tables rules to route the traffic in and out of the BLX. So this is a sample packet flow wherein like incoming traffic, how it enters through the Linux interface and is processed by the BLX. Second, we have the most common mode and widely used mode, which is the dedicated mode. In case of dedicated mode, the kernel interfaces are moved to the BLX network namespace. If you see here, the interfaces ETH1 and ETH2 have become part of the BLX network namespace. The packet can directly come to the BLX namespace and it will be processed. So there is no need for IP tables rules here. So what happens here is the traffic will still has to pass to the Linux stack. So hence we may not get the line rate performance. To solve this problem, we bring in a new dedicated DPDK mode. It is same as dedicated mode, but we will be using an additional DPDK layer to it. You can see here, now the NICs are part of the DPDK. So whatever packet which lands on these NICs will be directly given to the BLX user space, and there will be no overhead of the kernel. So what we indirectly getting is there is no delay in packet processing, hence we will be able to achieve the line rate performance. So we have another special mode, which is again a subcategory in the dedicated mode, wherein there is no dedicated management interface available in the host. What we do here is we create certain NAT rules within the BLX to manage the host. So here if you see this picture, we have an internal V pair, BLX1 and BLX0, which is created to communicate between the kernel and the BLX namespace. We are creating a INAT rule for a different public IP other than the NS IP. In this case, if you see 192.168.1.3, which is pointing to 192.0.0.3. So whatever traffic that comes from outside to this particular IP will be rerouted to the kernel. So when someone wants to access the host, he will be using this NATed IP. And for the regular BLX access, he will be using the NS IP. So this comes into picture when there is no dedicated management access in dedicated mode. So in the last, I'm going to show like the comparison between the different modes and when to choose which mode. So the host doesn't allow a dedicated data NIC or a management NIC for the BLX. If the throughput requirement is low, then we can go ahead with the shared mode. In shared mode, the BLX will be reachable on any of the IPs configured on the Linux over the port 9080 for HTTP, 9443 for HTTPS, and 90224 for SSH. The ports 9080 and 9443 stay same in case of any modes, and we can tune these management ports in case of shared. And the NSIP is 192.0.0.1 in case of shared mode. And if the user has a data NIC available and he also has a management NIC, and if the throughput requirement is not very high, then he can stick to the dedicated mode. In a very similar setup, if line rate requirement is needed and he's having a hardware resource like a Baremetal resource, then the user can use the DPDK mode. And as I said earlier, if there is no availability of a dedicated management NIC, then we can use special mode on top of the dedicated or DPDK mode. And in all these dedicated modes, we will be having a custom NS IP, and hence the SSH will work on the default port 22. So this marks the end of Citrix ADC BLX Basics. This has given you certain level of understanding about BLX. we will directly jump into the next part, the main part of this video, which is deployment of Citrix ADC BLX using Terraform. So yes, from the Terraform perspective, we are going to see the introduction about the Terraform and the advantages of using Terraform and the various Terraform plugins developed for Citrix ADC. We are going to talk about how to create a Terraform host to deploy Citrix ADC BLX. And finally, we are going to show you how we are using Terraform scripts to deploy a BLX cluster from the scratch. Let's move on to Terraform introduction. Terraform is one of the popular infrastructure as a code tool, and it's used for managing the infrastructure in a safe and efficient manner. And the code is declarative in nature, and it uses its own proprietary HashiCorp configuration language. So this is a sample example, like how a resource will look like in a Terraform perspective. So here in this example, we are seeing a Citrix ADC BLX LB vServer. So we are taking all the different parameters here, like the vServer name, the IP, the port, and the protocol. So next, we are going to see the advantages of Terraform through its workflow. So the resource definition becomes very easy in the Terraform script. Like for example, in the screenshot, whatever I have shared, you can see we are creating a CSV server and a policy. And in the third resource, we are trying to bind the CSV server with the policy. So how it works? The initial step will be, after creating the Terraform scripts, we will do a Terraform plan to see what is going to happen. So it will give a preview of all the changes which are going to happen. And then once we are okay with it, we can do a Terraform apply to apply the changes or to add the resources. The same Terraform apply will be applicable for the subsequent changes that will be done on the infrastructure. And finally, to destroy, we use Terraform destroy to clear all the configurations or the resources we added. And it becomes very easy for any user to use Terraform. Next, we have certain Terraform plugins developed for Citrix ADC. So we have a generic Citrix ADC plugin which will be used to add or remove the ADC configuration. Any configuration which is done on the Citrix ADC can be achieved using Citrix ADC plugin. And even the cluster can be created using this standard Citrix ADC plugin. This is already available on the GitHub. And what we have done for Citrix ADC BLX is a new plugin. So here, using the Citrix ADC BLX plugin, we will be able to bring up a BLX or destroy a BLX in any of the modes which we discussed earlier. Next, we are going to talk about the Terraform host. This is the place from where we will be deploying or running all these Terraform scripts. So these are the standard set of things that has to be done on a host to run the Terraform. The first thing is, like, we need to download the Terraform packages from the terraform.io website, and we need to place the binary, the Terraform binary, in the standard system paths in your host. So this will make sure the Terraform is available on your system. Next, we are going to configure the Terraform host to load the Citrix plugins. So for this, we need to download these plugins. As I said earlier, Citrix ADC plugin is already available in the GitHub, and Citrix BLX plugin will be soon published in GitHub. The first thing is we need to download the Citrix ADC and Citrix BLX plugins to your host. Then we need to create a Terraform RC file in the home directory of the user from where the Terraform scripts will be run. So why we need this Terraform RC file? This is because we are letting the Terraform know that the plugins are available in the same host under a certain directory. So that's why, like, we will be setting this file system mirror path in the Terraform RC file. So that the Terraform can go there and pick those plugins. The file format the path format looks something like this. Like, after the file system mirror paths, you need to give this registry.terraform.io/hashicorp, and we need to give Citrix BLX/001/Linux_AMD64. Basically, it's a plugin version and platform. Once this is done, we are set to go. So in the demo, we will be showing how to set up a Terraform host from the scratch, and then we will be doing a cluster deployment of Citrix ADC BLX. So this is the flow. So we'll be using the Citrix BLX plugin to install BLX on 2 Linux servers parallelly, and then we will be using the standard Citrix ADC plugin to form cluster between these two BLX ADCs, and then we'll be adding an LBV server and a service on top of the cluster, and we will show you a test run like how this LBV server is working. All these things are going to run by just triggering a single Terraform script, and the whole topology will be up and running in few minutes. So we will be seeing the demo.
To install Terraform on the Terraform host, we can download the Terraform executable from the Terraform website. Our host is a 64-bit Linux machine. We'll copy the link and download it. Unzip this file. As you can see, this contains the Terraform executable, which now needs to be placed in the system path. We can now move this executable to any of the given paths. As you can see, Terraform has been successfully installed on the host. Now we need to configure our Terraform providers. As the Citrix providers aren't available on the Terraform registry, we need to manually install them. For the Citrix ADC provider, we can download it from the respective GitHub page. We can go to the release section and download the latest version. The Citrix BLX provider plugin isn't available on GitHub currently and can be procured from the engineering team. For this demo, we have already placed the plugin in the Terraform host. So now, to configure the automation, we need to mirror the Terraform registry from the directory from where we're running the automation. We're running the automation from the root Terraform automation directory. So over here, we need to mirror the path to the Terraform registry. So as you can see, this path is mirroring the Terraform registry path on the file system of the Terraform host. Over here, Terraform registry.terraform.io HashiCorp is the initial path, followed by the plugin name, the version number of the plugin, and the operating system on which it is running. Ours is a Linux host, so we can now move the plugin to this directory. Similarly, we need to do this for the Citrix BLX plugin. Now we're copying the Citrix BLX plugin to the mirrored path. Now for Terraform to detect this mirrored path, we need to create a Terraform RC file. This is created in the home directory of the user. So over here, we create a Terraform RC file, which is a hidden file, .terraform rc. Over here, we need to give the path of our Terraform automation. That is from where we are running the automation as a file system mirror path. So once this is done, we can go to the Terraform automation directory and initialize our provider plugins. For doing this, we can create empty declarations for the two plugins we are initializing. This is the Citrix BLX plugin and the Citrix ADC plugin. We can now do a Terraform init. Terraform has been successfully initialized. It has found the two plugins and initialized. Okay. So if we now see Terraform version, it will detect both the plugins that we have currently configured. In this demo, we'll be provisioning two BLXs, which will be clustered, and then an LBV server with a bound service will be added to it. To achieve this, we are splitting our configuration across multiple Terraform configuration files. So we'll analyze these files one by one. First change we need to add is to our provider configuration file. Over here, for the Citrix ADC provider plugin, we'll set the endpoint to the cluster IP with its respective credentials. Moving to the BLX resource, over here you can see we are creating two BLX resources, which are the two BLXs we want to configure. Inside the resource, for a given BLX resource, we have declared source RPMs that need to be installed on the BLX host. The path that is given is the path of the RPMs on the Terraform host. Secondly, we are given the host credentials of the BLX host. That is the IP, username, and password. Thirdly, the DPTK interfaces. These refer to the data interfaces that will be dedicated to DPTK on the BLX deployment. In the config section, we set keys which are applicable to the blx.conf. Over here, interfaces refers to the sub interface that we'll be creating for the management access to this BLX. And IP address is the BLX management IP address. DPTK config refers to the BLX cores that we will be configuring, and default gateway refers to the default gateway to be configured on the BLX. Along with this, we can set the password the BLX will come up with and the license file that must be applied to it. The same resource is then replicated in BLX2, where we provide the source, the host configuration, DPTK interface, the BLX configuration, password, and license. We now analyze the cluster resource. So the cluster resource, we set the clip IP and refer to the two BLXs that we have configured in previous configuration over here. The endpoint of the cluster node is the BLX endpoint. Backplane is the interface over which the cluster nodes will communicate with each other. And the IP address is again the IP address of the BLX we have previously seen. This way we'll be able to cluster two BLX. Finally, in configuration, we see we're enabling the LBV server, LB feature. We're doing this by leveraging the NS feature of the Citrix ADC plugin. You can see we have added a depends on to the resource with the dependency on the cluster we have created, so that this configuration will only be applied once the cluster is up. Citrix ADC service S1 refers to the service that we will be binding to the LBV we have just created. And finally, we are adding a snip which is required for connecting to the service. We'll now do a Terraform plan. So you can see in the Terraform plan, we are going to add the two BLX resources that we went over, the service, the subnet IP, LB, and the cluster resource. Before we do the apply, we can check on the BLX host that BLX isn't running. We'll now do the Terraform apply. You can see here the BLX creation is complete. Over here, and after 2 minutes, the cluster was successfully created. Post which, we added the configuration on top of the cluster for bringing up the LBV server with the bound service to it. We can now SSH to one of the nodes of the BLX. As you can see, it's part of the cluster. Over here, we can see the DPDK interface that we had dedicated has come up. You can also see the license has been successfully applied. We'll now check the GUI of the cluster. So check the cluster. As you can see, the 2 nodes have been detected. Going to LBV server configuration. You can see one LBV server has been configured. We can send a request to this LBV server. As you can see, the LBV server displaying the page which is bound to the Apache service that it was bound to. Now we can destroy the resource. That is, it will remove all the configuration that was done and stop BLX on the host and return the interfaces from DPDK back to the kernel. So we'll do a Terraform destroy. It's removed the LB and the service configuration and the cluster configuration. As you can see, the box has gone down. On the host, we can see that BLX has been stopped.
This marks the end of the demo. As an ending note, the video covers the basics of the BLX and it should help the user to deploy BLX using the Terraform. Thanks for watching.